All right, good afternoon, good morning, whatever time of day it is. Today we are going to go over trig ratios. Another word we could use is trigonometric ratios, trigonometric functions. It is a very hard word, so we're going to stick to trig, okay? We are still doing right triangles, so nothing new when it comes to shape and the properties of it. So everything that we've been talking about, we know. And I just kind of want to start off by saying that we use trig functions to find missing parts of the triangle. So lately we've been going over like Pythagorean theorem, how to find the missing sides, how to find the missing sides of special right triangles. So when the angles are a certain degree measure. Now we're getting into the fact where, hey, I can actually use the side lengths to find the measure of the angles, okay? But today we're going to work on something a little bit more simpler than that. We are just going to work on actually finding the ratios, okay? So first I kind of want to label these parts of the triangle, okay? So this part of the triangle that is always across the 90-degree angle is always the hypotenuse. Always, always, always. Okay, always the hypotenuse. So if I am looking at the perspective of angle C, which that does matter, the side across from it, diagonal from it, is known as the opposite side. And then the side right next to it that helps create angle C is known as the adjacent side. Okay, now the hypotenuse never changes. It is always going to be the side across the 90-degree angle. But the opposite and the adjacent sides of the triangle will always change depending on which angle we are looking at, okay? Because side length AC to angle C is known as the adjacent side, but to angle B, it is known as the opposite side. So we have to be careful with that. Okay, so now we're going to use this information to kind of classify our trig ratios. So the first one is sine, and we abbreviate it as sin, S-I-N, and it is known its ratio is opposite side over hypotenuse. Okay, so opposite side over hypotenuse. The next one is cosine, and it's abbreviated as cos, and it is known as, its ratio is the adjacent side over the hypotenuse. And then last but not least, we have tangent, which you guessed it, we abbreviate it as tan. And it is known as the opposite side over the adjacent side. Alrighty. Now, I am asking you to remember this. So let me tell you how you remember this. We have a cool term or funny term known as SOHCAHTOA. SOHCAHTOA. This SOHCAHTOA tells us how the ratio shall go. So for sine, which stands for S, it's opposite over hypotenuse. And that's exactly what we talked about here. Then for cosine, which starts with C, is adjacent over hypotenuse. And then for tangent, we have opposite over adjacent. Okay, so this right here will kind of help you remember. If you can remember this funky term of SOHCAHTOA, it will help you remember the actual ratios that they should go in. SOHCAHTOA. Alrighty. So let's do an example of what we're going to go over today. So there's going to be probably 3 different parts of this notes. So this is the first part of the notes. So the first part, we're going to talk about ratio. We're just going to practice ratio building. Okay, I want to find sine of A, cosine of A, and tangent of A. Okay, so if A is my perspective, then my opposite side is 5. And my adjacent side is 12. And my hypotenuse always is 13. So then I just need to rely on SOHCAHTOA in order to put my ratios in the right spot. So for sine, it is opposite over hypotenuse. So the opposite side is 5. And it's over the hypotenuse, which is 13. For cosine of A, it's going to be adjacent side, which is 12, over the hypotenuse of 13. And then tangent of A, we're going to do the same thing. So it's going to be opposite side over adjacent. Okay? And that is pretty much like it when it comes to ratio practicing, like practicing setting up our ratios. Okay? So I kind of want to start with an example. So let's import a photo. Not there. Okay. All right. So this is the example problems that my classroom did. And I'm going to do the first 2, but I want you to do the last 8. And then I'll have you turn it in. Okay. All right. So the tangent of Z. So if we remember SOHCAHTOA, okay, tangent is opposite over adjacent. So opposite side, 21, over the adjacent side, which is 28. Now, this can simplify, so we need to simplify. Do not forget to simplify. These both can be divided by 7, so it'll be 3 over 4. All right. Number 2 says cosine of C. So remember, cosine is adjacent over hypotenuse. And the adjacent side to C is 16. And the hypotenuse is 34. So it ends up being 16 over 34. And these both can simplify by 2. So 16 divided by 2 is 8. And 34 divided by 2 is 17. Okay, so I want you to just go through and input the rest of these, and then we'll move on to how we can utilize these ratios to find missing parts of the triangles. Bye.